I get it. Yeah, babe, let me know when you've got that link sent out and we'll see who comes on. For whatever reason, we didn't have access to the webcam, but now we do. So, guys, we had a little bit of technical difficulty. For whatever reason, we set up the live and sent the link out, and we were unable to get access to the webcam for the live, and so it wouldn't go live with us. And so we had to reset up a new live session and resend out the links to everybody that was on. There were 4 or 5 people on at the time. So I'm hoping that we've got this solved, and I'm just waiting for a few people to come on. Mrs. Honeydew just sent out the new link, and so we'll see what happens. But we do have some exciting news. I've been talking with one of our Patreon users, and he's built several stoves, and he just notified me what he'd been doing, and it's good news. Hey, babe, did you get that link sent out? Cool. Let me send a message out. Hey, Mitch, how are you doing? Hey, Dirk, how are you doing? So I'm just waiting for a couple more people to get on, but uh,
Did we get it figured out?
yeah, we got it figured out. Mitch is on and Dirk is on.
Oh yeah.
But anyway, Mitch, I got a hold of Dirk and we had a nice long conversation about several stoves that he had built. And
I said it 3 times, so I wasn't sure it went through.
oh, you sent it 3 times. But between the two of us, uh, well, actually, it was Dirk's discovery. Um, but I tried it, and um, the front of my stove doesn't seal like his so much. But anyways, it is kind of crazy because you can just get the stove started and get it good and hot and going, and you can just load it up completely full with new wood and just shut it down completely. What Dirk had done was instead of letting the air go in uh, to the secondary burn chamber um, on through the same damper that you use on the door, he drilled a hole through the side of it and plugged the front one so that it just had its own air intake into the secondary burn chamber. And that changed everything. Um, you can literally you get the stove just warmed up and going, and you load it full of wood before you go to bed at night, and 4, 5, 6 hours later, and you just completely close the front off, so the damper's completely closed, and 4, 5, 6 hours later, it's still giving off heat, and there's still a bed of coals in there, and you don't necessarily have to worry about um, the stove and the vacuum that it creates sucking so hard and sucking all the warm air out of your house, because it's just a 5/8 hole into the secondary burn chamber. Um, and I'm guessing that as it creates a vacuum and it sucks that in, that a little bit of the residual goes back down into the burn chamber, and there's enough there to keep it going. And because of the insulation around, it keeps plenty hot to keep it going, but it just burns slowly, and it still doesn't create any smoke. Um, it is it it's actually crazy how well it works. And so um, I'm gonna have to do some augmented plans to my stove and figure out how, but I want to make that hole. I want to be able to close it off or put it on either way. I want to be able to burn it either way. So I want to have that original hole that I have in the front of the stove between the secondary flap and the main door. I want to be able to shut that off and then turn on the air just directly into the secondary burn. But that was some pretty exciting news. Um, we're getting into the part of the season where I think next fall we're gonna kick up, and there's gonna be a lot more interest in the rocket stove. going into winter for whatever reason. That's just kind of the way things work. Um, and so Melanie and I are kind of in a transition period. Over the past 2 years, we've done a lot of different, how would I say, infrastructure type projects, whether it be on um, some other people's properties or on our property as well. And so, what we're planning on doing is we're wanting to put together a class. Um, I'm thinking in June, so that we can, and it's going to be focused around Aircrete and the Aircrete pumping system to pump Aircrete into existing walls and existing structures. Um, and I want to keep doing these Sunday lives for my Patreon viewers. I do have a feature on. Um, I have a feature on our Etsy store that allows people to buy a 30-minute consultation, and I've done some of those and called people to ask them about it, or and set up calls with people so that they could just kind of ask me about anything, engineering wise, having to do with some of these projects that I've done online, when they're trying to recreate them and whatnot. And they just tell me about their specific situation, and I advise them on what to do and how to be successful in um, putting together these Aircrete projects and whatnot. Now, that being said, I want to keep doing these lives for all my Patreon users so that if they have any questions about anything that they're trying to do, it's just open forum for anything having to do with Aircrete or anything having to do with the rocket stoves. Um, Now, this class that I'm putting together, um, it's going to be focused around Aircrete and insulating the walls. However, we're going to have a couple of what I call show and tell days. So, one infrastructure project that I've done that I'm really excited to do classes on. And I think these classes over time are going to grow and grow, and the interest is going to grow just simply because um, of the amount of value that they can add to properties and whatnot. And so let me just tell you a quick little story. So, an 86-year-old lady bought a property just across the valley from me. And her son wanted it, and they just dove in head first. But this property had been without water for a quarter century, for 24 years. And no, you can see evidence of dry wells and springs that people had tried to create and whatnot, of people who had tried to solve the issue, but they had failed. And I have a little bit of a background in geotechnical engineering and been involved in well drilling and pumping and developing springs and whatnot. And so this property was just basically, they bought it for grazing land prices, 280 acres, up on top of a mountain. They basically bought the whole mountain, and there was a house up there, but it had no water, and the plumbing was in bad repair. And so I helped them remodel it, redo the plumbing and whatnot. And I advised them where on the very bottom of their property that they could drill a well and get some water to that. However, it was 1,600 feet up the hill with about a from the static water level, about an 800-foot elevation rise. And I was able to 2-stage pump it using solar pumps up this mountain and got them 5 gallons a minute. I created and engineered a retaining wall system to allow them to drop a 2,500 gallon cistern in this hole. And it was a cistern that wasn't meant to be buried. It's not supposed to be buried. And so, but it has a retaining wall system around, and I did it very inexpensively with cattle panels and whatnot. I developed a spring for them and cut a spring out that feeds into 2 terrace ponds that I excavated out and built for them. And now all of a sudden they have this property that, they paid grazing land prices for that 280 acres, and it's worth $1 million or $2 million. Who knows what it's worth essentially, but from our best estimates, it's worth at least $1.5 million, and they didn't even pay 1/3 that for the property. And so some of these things that I'm doing for people that are off grid, and these stair-step solar pumping systems, and developing the ponds and developing the spring. So I developed a spring on my property that feeds into a couple of ponds as well. And so there's a lot of value in this class, just above and beyond just the Aircrete and insulating walls and whatnot. But there's going to be kind of some show and tells, so that people could maybe that are thinking about, getting out of the city and going off grid, can buy a piece of property that, traditionally in the past has been worth almost nothing because of its location and where it's at. And they can, with somewhat confidence, understand that it is possible to get water up to these places, or to develop springs in places where people had been unable to develop springs. So anyways, let me see, who do we have on? We've got Mitch Anthony, Derg, and William Walters. So anyways, I want to do a little bit of a Q&A, and I want you guys to ask me any question you want to about anything about Aircrete, because for whatever reason, I had a great deal of success with Aircrete right off of the bat. And I was like the only one out there in the ether that had tried it and then was immediately successful. And I didn't have any issues with the collapsing and whatnot. I have since fielded thousands and thousands of questions on Etsy about my mix designs and whatnot. And then I went in and redid them all. I redid all the, so they're like little mini booklets. My wall panel mix design PDF is like 25 pages now. And so I explain every ingredient, why I chose to put it in, what you can do for an alternative to it, and all these questions. So, but anyways, do you guys have any questions, especially anything of maybe you want to ask me, or even Derg, who had kind of figured out this discovery on how you can, get I don't like J tubes, and a lot of people like J tube configurations for rocket stoves, but I find them to be very problematic because it's kind of a teeter-totter thing, and the back side of the J tube, the hottest part of the stove, is right at the bottom of it, and it actually works against you and can become a a chimney inside your house. And if the situation outside your house, whether it be the barometric pressure or the wind or the humidity or the temperature, comes to where it puts your stove in a situation where all of the heat energy is no longer pulling, it can do what's called a reversal. And I find the J tubes very problematic. I've always liked batch boxes, and that's what I kind of concentrated on when I started building stoves. Dirk Perrin has kind of figured out the exact same thing. He's been doing these things for 30 years. And so if you want, go ahead, ask a question, and let's just do some Q&As right now. And it says Tim was on the other one, but obviously Tim didn't get the new link. Crap. But you sent the link out to everybody on Patreon,
Yeah, and
right?
I wanted to go through it, and so I tried to resend it. And some people, I think, got it 3 times.
Okay. So I'm going to start asking some questions of you guys so I can get to know you a little better. I had a great time talking with Dirk about things that he had been doing over the past 30 years. And I know where he's from and, what part of Idaho he's in and whatnot. And I'm just curious, Mitch.
If you guys are willing to share.
If you're willing to share, I'm just kind of curious, what part of the country are you from? Jim Allen says, on the automation projects, temperature probes are good to 700 C or about 1400 degrees Fahrenheit. Where could they not be installed due to higher heat? Well, I regularly get way over 1400 degrees in the back of the burn box and up in the secondary. And I'm just assuming that in the riser, it's got to be at least that high as well. So I am looking, and I think he's asking because of his interest in the Raspberry Pi and different things. And so I'm looking at doing heat probes within the first couple inches of the front of the burn box. And I think that would give us a good tell of what kind of fuel still remains in the box. Because I regularly get 1400 degrees within 2 or 3 inches of the front of the burn box. And in the back, it's regularly over 1900 degrees. Mitch says he is remote BC, Canada, British Columbia, Canada. Well, I'm in remote North Idaho, so. Jim Allen is asking about the bottom of the downdraft. Now, I had thought about putting heat probes in like 2 or 3 locations, and then you could take the XY graph on them by doing experiments. So, like, let's say you put a probe within 2 or 3 inches of the front of the burn box, and it has a certain reading, and then the probe at the bottom of the downdraft shroud has another reading, and they are going to be much lower temperatures at the bottom of the downdraft versus like at the top and whatnot. And then if you looked at the XY graph between the one at the front of the box and the one at the bottom of the downdraft and looked at how much fuel remained in the burn box, that would give you an idea of how to write the code. The if then, if this probe drops below this temperature, then it would take a certain action with the stair step motor to open and close the draft. Now, that being said, it would also kind of let you do some experiments to where you could just maybe have one probe on there and it would tell the tale of all of it. There would have to be something written in the code where if it were under a certain temperature and it was just cold and then it started heating up, you'd just have to let it ride and let it go as long as it was rising. And then once it hit and peaked out and started coming down again to a certain point, then you would know that your fuel is being diminished. Okay. So Jim Allen, there are some probes up to $3,000, 3,000 degrees, but they're pricey. Yeah, and I don't think we need those kinds of probes. I think the probes that you have that go up to 1,400 degrees Fahrenheit or 700 C, somewhere in there, are plenty good. You just don't want to put them in the hottest part of the stove. Dirk Perrin says Darwin stove burned all winter, 24/7, and it was 21 below, and it worked flawlessly all winter. I burn it out. I burn out 2 1/4 inch. I'm not. Oh, he has well casing updraft pipes. I talked with Dirk in detail about his system. He has the well casing updraft pipes, and he put the double wall Aircrete insulated pipes in certain areas of his updraft as a kind of it ends up being a secondary riser almost to just keep the flow going and keep that negative pressure in the pole going. Jim Allen says regular probes are cheap, so maybe no big deal if they burn out, right? But I don't think they would burn out if you placed them in the right place. Okay, this is where I ran into some problems. Me and another guy were looking at it. The microcontrollers have 15 to 20 inputs, and you could go online and get different schematic diagrams for what each input is for and whatnot. And so the problem is you find several different diagrams and they're all different. And so it's going to take a little bit of experimenting with whoever puts together that system. Okay, William Walters, he says 2 questions. What is the smallest stove that works under your design? How thin can an Aircrete panel hold up? I think of designing a hard-sided camping trailer using Aircrete for the sides. You could scale the stove down to however small you wanted to scale it down. But if you went, say, instead of a 7x7 box and did a 6x6, you could probably run your riser instead of a 4-inch hole, maybe a 3-inch hole. And you just have to make sure that your double-walled insulated Aircrete stovepipe has at least a 4-inch inner diameter, so that the volume of air that it vacuums out would be more than the riser could ever push through it. That way you end up with a negative pressure system the whole time. The probes have a standard 6 millimeter thread and could be installed with rib nuts. Yeah. And, you know, the thing about it is if you put the probe right against, within the front 2 or 3 inches of the burn box, right against the refractory mix, I don't think it would ever get over the 700C. And I think as long as you did your tests and watched the temperatures rise and whatnot, and then watched them decline and watched how much fuel was in the burn box, you could probably do it with one probe. But I'm thinking if we had 2 probes, one that talked back and forth between them, one at the bottom of the downdraft and one at the front of the burn box, it may end up being a little more better. William Walters says he grew up in Indiana and now lives in Aurora, Colorado. What's the elevation there in Aurora? Yeah, that interests me. So one thing I talked about Dirk Perrin with, I'm looking at a comment that he made that he burnt the stove all winter. I think he said he came up with the terminology BDBB, which is before Darwin's burn box, because he's been running rocket stoves for a lot of years, and before the burn box and whatnot, I don't know if his wife didn't think it was safe enough or whatever. This was the first year she let him put the one in the house, and he had been through 2 or 3 different Blaze Kings, and I call them Smolder Kings because I'm actually replacing one of those Blaze Kings with a rocket stove for the same lady that I did all that work on her property for. And for whatever reason, because he's in a part of Idaho where it gets 20 below zero regularly during the winter, his furnace would have to kick on to augment the heating of the house when he was using the Blaze Kings and whatnot. And this was the first year that his furnace never kicked on, and I just thought that was kind of an impressive fact. So Mile High, so he's way over the 5,000 foot mark, and so I'm guessing he gets some low temperatures up there as well. So Dirk Perrin, if you're a 7x7 burn box, single pour, would you use wire mesh in the pour? All right. So I'm actually developing and I think I spoke with Dirk about this on the phone. I'm developing a form that is out of sheet metal, and it's going to have an aluminum on the inside so that when it burns out, it just kind of melts away. But I want to do a burn box in a single pour. And I am thinking that on the outside of the form, I will put like some rabbit wire or something so that, because with these really, depending on your situation and whatnot, and how you, what I mean is the extreme high or low temperatures that you might get versus the medium temperatures. Some people might have to set their stove up with several pieces of Aircrete insulated stovepipe so that they're running like over 12 feet of that stuff. And when you end up doing that, sometimes it pulls and vacuums so hard that you end up getting really high temperatures up around 2,800 degrees in the back of the burn box. The highest I recorded was 2,871 degrees. And so it's almost just 100 degrees under 3,000. And I ended up getting some just hairline cracks. And so I was super glad that I had some kind of mesh on the outside of the burn box that if it does crack, it doesn't, it stays in place. And so I'm thinking that for a monolithic single pour, I will go ahead and put some, hey kiddo, I will go ahead and put some wire mesh around the outside. I don't want it on the inside where it gets super hot. But as that temperature moves through the like maybe 1 inch of refractory mix, I think it diminishes enough that it would never melt that out. So. I really like William Walter's question about scaling down the stove, because there's a lot of people. In fact, I fielded a I sell those 30-minute consults, and I fielded a consult for a gal that was in Canada. She was up in British Columbia as well, but she was just wanting to heat her camper, which was just a couple, maybe 300 square feet. And in the configuration that my stove is here, I think it would be too much. And so I did give her and advised her on how to do the equations between the size of the stovepipe and the size of the hole in your riser and how big your burn box is, to try and scale it down a little bit for her. And I even advised her that she might want to shorten the riser a little bit and have more of a squattier stove so that it worked a little better. So I am very much this fall considering making a scaled down version. It's funny that people are wanting to scale it down because I had one set up in an offsite shop, and some of their family came in from Seattle, and they wanted to see it burn, and so I started it up. And of course, that was a completely uninsulated shop, and it was just roaring red hot. And he's like, well, if you're going to put this in your house to heat your house, you're going to have to make it bigger, aren't you? Because it just had this little burn box, and I just put a few pieces of wood in it. And I'm like, no, I don't think so. The amount of BTUs that you get out of a small amount of wood is pretty incredible. So. Well, guys, ask a few final questions. I'm going to get down to the last 5 minutes here in just a second. I know I was about 15 minutes late getting on, but I actually hopped off of to come in here and do this live. And I want to keep doing lives so that anybody who's on Patreon can pretty much do a Q&A, and they can ask me anything about what they're trying to figure out with what types of projects that are trying to reconstruct that I've done online. So. I'm going to give them a few minutes to just see if they want to ask a couple more questions, and then I'm going to go get back on the excavator.
Sounds like a plan.
Okay. William Walter says, what about the camping travel? What is the smallest stove that works under your design, and how can the Aircrete panel hold up?
So how small can you make it for portable versions for camping?
Oh. Well, I actually have a camp stove that I'm gonna augment and make a rocket stove out of. But you could scale it down. It would be kind of interesting if you scaled it down and just had a shorter riser, and then maybe one piece of Aircrete stovepipe out, and being able to, use it for like a camping situation. But I haven't done it. And as far as trailer panels go, using Aircrete for insulation in them, I just, man, I'd have to do a lot of experimenting with it. But if you did, I mean, I have a tiny house that's on a car hauler trailer, and it's just got stud walls on it. And I can't imagine that if Aircrete was encased in those, that it would be an issue. I would think that it would hold up just fine. But it's hard for me to talk about something I haven't done. Dirk says, call me again. This typing is too much. Right. Jim Allen says, how freely does the damper slide and the servo motor I'm looking at? Around 2 pounds of force. 2 pounds of force, I think, would be plenty. If you used a servo motor, especially one that had an auger type gear, it would have a much greater mechanical force to pull it back and forth, because it would be screwing it back and screwing it the other direction. And essentially, when you set up your Raspberry Pi, you'd have to tell it when the stop point is and where the other point is as well. One of the other things that I'm thinking about, Jim, just so you know, is putting the stop as just 180-degree flap in the back of the stove as it exits out and goes up. And that way, it completely shuts it down, except for just a small hole. You want it to still maintain a little bit of a negative pressure, but and that's kind of what Dirk has figured out with just that small 5/8 hole going in there. And there's no back puffing of smoke or anything like that. None of that ever happens. So wire mesh panels in trailer walls, I would do it. I think if you put, say, 2 layers of wire mesh of like the rabbit wire, one on either side of the panel, I can't imagine that it wouldn't hold up just fine, especially if you made the panels maybe only 16 inches wide and then stood them up, and then mechanically put them together after that. And Mitch Anthony says you might use an electric window motor from an old car for free. I think what Jim's talking about is servo motors, and they're like motors that are in a printer, and they know exactly when to move and whatnot, and you can actually write code that talks to these motors. And so I think
Jim is also wondering if it's worth it with Dirk's solution.
Yeah, with Dirk's solution may not be worth doing. Now, I'm wondering, yeah, because when you think about it, my whole idea of doing the Raspberry Pi and, I mean, it's a complicated thing. You'd have to have a little solar panel in your window on the southern facing portion of your house that ran a wire and slowly charged a battery that would run the servo. And then, and that battery would also run the 5 watts that it takes for the microprocessor. And so it is a little bit of a complicated system. And Dirk did figure out a mechanical way to do it. And I wanted the same thing, Jim. I really did. Steppers versus stepper motors, steppers versus servo motors. Yeah, I think a stepper motor might be the best alternative, but it would be kind of fun just to do, though, Jim. It would be kind of fun to set up a system where, I mean, because you look at these complicated stoves, the newer, like, say, Blaze Kings and whatnot. I mean, they're expensive stoves, and you have to have an AC plug-in that plugs in, and it works on a thermostat almost. The problem with them is because they work on a thermostat and whatnot, they damper it down so much that it creates a ton of creosote, and it really just it is a bad alternative. And the thing about why I think it would be worth doing and why it's kind of fun is because it's on a rocket stove that doesn't create any creosote, and it just might. So many people believe so much in these automated systems that are on the back of their stoves right now that plug into AC, that it just might bring it that much closer to mainstream. Jim Allen says, "Yep, it'd be fun." Yeah. All right, guys. I really appreciate all you guys getting on. And Jim Allen says, 2 friends are chimney sweeps to get rid of creosote. Yeah. Well, just get my rocket stove and you don't have to worry about creosote. That's one of my biggest things that I wanted to do. I wanted to develop something that burns so clean and so hot that it just did not create any creosote. And that was one of my main goals. And so it seems like I've kind of achieved that, and I'm really happy about it. And the fact that it burns way less wood. I mean, there are people up here that burn 10 cord of wood, and I have an completely uninsulated house, and I think we burned about 3.5 or 4 cord of wood. So, all right. Well, I will talk to you all next week, and just think of any questions that you have with anything that I've got going on. I have a lot of projects that I'm working on between animal shelters, and I'm looking at doing a micro hydro project, and so I want to hear all your guys' input and what you think about those things. I will talk to you later. Bye.